Hello, this here is a DEC Rainbow 100A with a VR201 amber monochrome display and a textile keyboard. We also have a RX50 dual floppy drive and a hard drive. Let's turn it on. As you can maybe hear, it's a bit loud. The hard drive of course makes some noise, but so does the AC fan that is on this A model. Apparently the B model would have a somewhat quieter DC fan. And here we go, we start seeing the startup screen. The CRT is suffering from something known as the CRT cataracts, which means the glue holding this protective glass to the tube is degrading, so it's looking a bit nasty. It's fixable, but a bit difficult and dangerous due to the risk of implosion of the tube. Anyway, from this startup screen we can either start the terminal mode, which is built in, or we can boot from a floppy. The A model cannot directly boot from the hard drive. That's something that came with the B model. So you'll always need a floppy on this one. And at the moment I only have one floppy for this, which is an MS-DOS 2.11. Let's try booting from it. Press A to boot from the first floppy drive. And there we go, it booted into DOS just fine. The Rainbow 100 has two CPUs, an 8-bit Z80, which can run something like the CP/M operating system, and an Intel 8088 CPU, which can of course run the MS-DOS, or the 16-bit CP/M 86. However, many DOS programs are specifically targeting the IBM PC hardware, which means they don't work here. And that's probably one of the reasons this computer wasn't a great success back in the day. Now let's turn off the machine to reduce some noise. So next I would like to do some restoration of this computer. First of all, of course, some cleanup of the exterior is needed. And then perhaps I will try to fix the secondary floppy drive, which isn't working at the moment. Hopefully it just needs some cleanup or something like that. And then I would like to figure out how to run more software on it. Maybe try and read the hard drive, see if there's anything on it, if it still works, and to document some of the hardware that's inside. To make it easier to work on it, I would like to retire the CRT for now, since it's in a bit of an unknown state. I haven't looked inside if there's anything leaking or anything like that, but yeah, I would like to work on the main unit without the CRT. And for that I have something cooking up, and that will be the point of this video, to show you what I've done with it so far. The video output from the Rainbow is handled from this 15-pin connector on the back. This port has power for the CRT, as well as the video signals and the keyboard traffic. So I don't have the original cable for the Rainbow, unfortunately, but I got this replacement cable from AliExpress. It has the same connectors, but I don't know if this cable really has the required current capacity of this CRT. It seems to work fine, but still, yeah, I'm not sure. So we connect the monitor to the computer using a cable like this, and the keyboard is actually connected to the monitor. So it's a bit like in some of the terminals made by DEC. So how do we connect some other display to the Rainbow? Well, let's take a look at the 15-pin video connector on the back. In the technical manual we can find the pinout for it, and here we can see that the mono video signal itself is on pin 12. There's also pins for red, green and blue, but these are not useful to me since I don't have the color graphics option. The monochrome signal apparently is NTSC compatible, so we could just break it out and plug it into any monitor that can handle the NTSC signals. That seems simple enough. And a couple of more things here. Of course, we need the keyboard data lines connected to a real keyboard so we can actually use the computer. In fact, without a working keyboard, this monitor would refuse to run. Then we have the 12 volts and some ground connections that are normally used to provide power to the CRT and the keyboard. So we could just make a breakout cable where on the one end we would have the 15-pin video connector, and on the other end some RCA jack for the composite video, and a RG11 jack for the keyboard. That seems simple enough. However, I decided to go for overkill, and here is what I came up with. This is still a work in progress, as you can see from how this connector is kind of botched in here. I got the pinout wrong in the layout. But what's going on here? Well, the simple part is the video signal, which is just passed through here from the 15-pin connector to the RCA jack. So this alone would let us connect to another display. The more complex part of it is the rest of it, where instead of passing through the keyboard signals, I decided to add support for USB keyboards. This was entirely made possible by this project on GitHub called LK201EMU, made by Paul Koning. It's an LK201 keyboard emulator which lets you plug in any USB keyboard and have it emulate the LK201 that this computer needs. What I've built here is basically the same project, except I've adapted it for use with the Raspberry Pico. This adaptation is still a work in progress. I still have to implement and fix some things, but for the most part it's working just fine. And of course my board here integrates both the video signal and the keyboard stuff all to the same board. So let's plug in some cables and try it out. For testing I have this cheap little LCD display here, which can take a composite video directly. But I found that I get the best results by using an OSSC in the middle. And for keyboard, let's try using my daily driver mechanical USB keyboard. Okay, let's turn on the machine. There's the main screen. Let's test the keyboard adapter by pressing T for terminal mode. And there we go. The keyboard is working as well. The display seems to have quite a bit of interference. I think this is entirely the fault of my PCB design. Perhaps the ground for the video signal should be isolated or something. If I remove the Pico from the board, much of the interference goes away, but then of course I wouldn't have a working keyboard. This is still good enough for now, just so I can actually work on the machine. Let's go to settings by pressing F3. And here we have some fairly basic terminal settings. And the smooth scrolling is something worth trying. So let's enable that. And exit setup. And actually let's reset the machine by pressing Ctrl F3 while we're in the settings. And this time let's boot to DOS. And there's that beautiful smooth scrolling. Of course, you might think using a PC-style keyboard on a DEC machine is kind of lame. And that is true. Using the LK201 would be much preferred. But with the support for USB keyboards, I actually now do have the option of using this. What I have here is a LK411 with the Nordic or Finnish layout. This is a DEC-style PS2 keyboard. See the do and help keys right there. So my keyboard adapter does have a PS2 connector, but I've not implemented any support for it yet in software. However, I don't really even need to do that. See, with the USB to PS2 adapter, this keyboard works just fine. So with the display and keyboard stuff all sorted out, I've now turned my attention to the RX50 floppy drive. I've spent some time messing with it, and here is the rundown so far. I went and opened up the Rainbow to remove the floppy drive. It comes out real easy without needing any tools. Then I opened up the drive and cleaned inside with a Q-tip and some alcohol. There was a bunch of dust inside and some dead insects, like this wasp or something. And I carefully cleaned the heads of the drive and made sure the soft pads opposite to the head are still intact. Also cleaned the linear rods and gave them a tiny bit of grease. The problem originally was that the B drive wasn't working. So here's hoping that with this simple cleanup we'll get the B drive working and have an easy time creating more floppies. And after putting the whole thing back together, I was able to boot from the B drive and everything seems to be fine. So the cleanup was a success. I have one working floppy that came with the machine. It contains an MS-DOS 2.11 with some of the utilities that came with it. I would very much like to avoid writing this floppy any more than necessary, and my goal really is to create another floppy. Maybe clone this floppy and then add some software to it for creating more floppies, or investigating the hard drive that I have here. But here's the problem. I can't simply take any of my double density floppies and have it working here. Floppies on the Rainbow, they need to be low-level formatted specifically to work with the Rainbow and the RX50 floppy drive. There are special utilities written for DOS that let you low-level format the floppy for the Rainbow using any IBM-compatible PC and a 1.2 megabyte floppy drive. The problem is that I don't have any other floppy drives that I could use on a PC. The only drive I have is right here, the RX50. So to low-level format a floppy, I would need to do it right here on this machine, and it should be possible. Looking at the manual for the DEC version of the DOS 2.11, the format command does have an extra I flag for low-level formatting a floppy. But for now, I have not been able to get it to work. Each time I run the command on either drive, I get an error message, format failure, even though the drive seems to be otherwise working just fine. So I'm a bit stuck here. My one other option would be to use a GoTech floppy emulator, which I have here. Maybe use it to boot to some other DOS version, or maybe CPM, and try to format a real floppy from there. But it turns out my GoTech has silently died while in storage. I have found some ways to transfer and run custom software on the Rainbow with the help of the serial port. For example, in DOS, I could use the ctti command to switch console to the serial port. And then, using the debug command, I could basically enter a program directly into the Rainbow's memory and run it. This way I can basically transfer small programs to the Rainbow. And I've also written a small assembly program that does basically the same thing, lets me enter data using hex values and store it all in a file. This would allow me to transfer even larger files through the serial port. So I guess the question now is there some program I could try transferring and running? Something that could help me with low-level formatting the floppies? Or should I give up and maybe start working on the hard drive instead? And I think this is where I will end this video, just so I can actually manage to edit and publish it. But I will definitely try to figure out how to proceed from here. Realistically, I will probably end up buying another Gotek or perhaps a floppy drive. So that's it for now. Maybe there will be another video from me, who knows. But in any case, thank you for watching.